As I mentioned in the morning, I'm very happy that we had really in-depth and very wide look at housing, from small to extremely large buildings of many types. And but I'm also very happy that we are going to get really deep look at the use of IC. That's just a very quick way of saying it, for the construction of data centers. And I have to thank Victor Sanvido from Southland, one of the speakers, for the idea that he brought up a few months ago when we had a catch-up call, and and for organizing this panel. So Victor from Southland, the mechanical perspective of data centers and other projects, is complemented by Joe Arcello from DPR Construction as the GC, and then Simon Harkins from now I have to remember Modular Power Systems, Modular Power Solutions, sorry, which is a wholly owned subsidiary of Rosendin, one of the main electrical contractors in the country. I know for the local people, these names are household names, but for people from around the world, just want to give a little context. And as you will see, if I use very Swiss understatement, this team has built pretty large projects, pretty large data centers fairly quickly. They have really accelerated the construction of very large data centers quite amazingly. So that's why I'm excited that they are here to share what they do and how they do it.
Little intros?
Yeah, we can do. We're making this up as we go, so bear with us. So we're going to do a little intro. And I'm Victor Sanvido, Southland Industries. I went to school here, and my teacher's right there in the front row. So if you don't like it, blame him. And I got a colleague I graduated with. So anyway, it's nice to be back with in this place. I left this place and went to work in the oil field in Alaska, then went to go and teach at Penn State for 13 years, and then I joined Southland, and we've been making things for 25 years. John?
Me? All right. After watching the last few, I feel a little intimidated, like I might be one of the lower dumb people here. So Simon Harkins, I'm the managing director of Modular Power Solutions. I'm also senior vice president at Rosen Holdings. So been doing modular for about 15 years. Went to school at Kansas State, got a master's degree in engineering, became an electrical engineer after school. Really just kind of gravitated to the Lego blocks, right? I was kind of a hyperactive kid, real busy. You'll see that throughout the presentation. I get real squirrely. But when we had the opportunity to go modular, 15 years ago, there wasn't a lot of adoption, right? It wasn't in the United States. It wasn't real commercially viable. Nobody really wanted it. Everybody wanted to talk about it, but we couldn't make it fit. The last few years of just seeing this rocket ship. And so, with the preparation of the things that we did and the effort that we put into designing and engineering and standardization, we've been able to grow a business from a $5 million revenue to $1 billion revenue over 8 years, and really 50 million to $1 billion in 5 years. So that's involved scaling, the almost 3 million square feet of facilities. And all of that right now is focused on data centers. So the graphic here is clearly not a data center. It's more like what everybody else is. But it's been a very unique moment in time and a growing curve and a big opportunity to kind of make an impact.
Hi, I'm Simon.
Sorry.
And John Arcello with DPR Construction. My first time here. Haven't had a chance to meet all of you yet, but spent the last 20 some years in DPR, where I started out here in the Bay Area and had a chance to go finish up school. And construction has just been in my blood. I love it. I don't want to disappoint anybody. I am not an expert in industrial construction. I'm just fascinated by people and how the behaviors drive their business. So we're going to have a full presentation to talk about how the group came together, and I think you'll see it. Hopefully we'll be able to answer some questions at the end.
Thanks, John. So first of all, I want to echo Simon's comments this morning. I learned an awful lot today. We are doing this presentation because we want to be able to explain what we're doing, and the only way you can do this is to actually have to present it. And so I think that's what we're looking at, and we've picked up a lot of good ideas along the way. So the title is From Snowflakes to Assembled Products. Every data center is somewhat unique. People will say they're all the same. They're quite different, and there's a lot of changes in them. So how do you take them into an assembled product? So what we're going to cover today is really, the problem statement. We'll do a case study on the Crusoe Abilene data center, which is the first of the Stargate projects. And then we'll talk a little bit about DFMA principles and technical strategies, because we have a bunch more that we're trying to do behind them, and what have we learned in the first one. And then really a little bit about a call to action and what do we think it means for the industry. So the problem statement in the case study, I think if you look at 2 years ago, 24 megawatt data centers people thought they were big jobs, and then it became 96s and 100, and then end of last year it became 1 gigawatt, 2.5 gigawatts. So you can tell the scale, and they wanted them done in about the same amount of time that you did the old ones, and you had less time to get ready to go. So we had to try some different things, and if you deliver it the same way you've always delivered it, you won't be able to go fast. So I think we're trying to explore and look at some of the things.
Yep. Take a little poll. I think, how many in the room, maybe online, are familiar with data center construction? There's about a third. So great. I think I'm not here to blow you away with any statistics or compete for the largest project or the fastest one in the world. We're really here to share some ideas of what really helped us come together and do something that we don't think has ever been done at the speed and scale of what we have before. So why does this moment matter for our industry? We've got really 3 converging things that are coming together. The limitations of really the workforce that we have. We have the deglobalization, unfortunately, where products are not going to be as available as we became so accustomed to getting in the last 20 plus years. And the third one is the scale, like the scale in which compute and AI and our technology that's serving all of our businesses is exponentially growing. There's some statistics around, we're going to double the number of data centers, by the year 25, from 25 to 2030. Like, I fully believe that. There's others that say slightly more than that, but if you think about any data center in the world as it is today, we're going to double that in the next 4 years from right now. What you see up on the screen here is a series of, I'll say, complaining and gripes, and we probably all have probably been pretty frustrated in our work settings of why can't we fix this? And like anything, it's the system, the problems we have right now are a function of how we've come together over the years. And so if we keep complaining and griping, then we should expect the same results. This is where we've really found, I think, something different that Victor's going to explain.
So I think when you're trying to build something and you put a new team together, they haven't been in the battle together. They don't know how each other works. They all come from different backgrounds. And if you pick them based on low price or some other random method, and they come into the job later than expected, there's no time to build trust. So you end up with a bunch of people who are trying to optimize their own piece and are sometimes working against the people who picked them, right? So I've got to protect myself, and I don't really care about you. And I'm going to optimize my piece, and I'll look for excuses rather than be part of the team who has to solve it. Project timelines, as you would expect, every time we see something that's not according to what was expected, we complain and cry about it. Whereas if we actually started solving it, the job would go faster. So we built in some extra buffers. And I think if you're trying to do something that is on the order of 10 to 20 times what you built last year in scale, you have to deliver that every 2 weeks. What took you a year to do, you do it every 2 weeks. Okay, and that's the next right away. So the only way to do this really is to collaborate. So let me talk a little bit about how we came together. The developer for this worked over here for another company. It so happens that DPR had worked for them over the years. Rosenthal had worked for them over the years. We'd worked for them over the years. You also look at the fact that our organization copied them on the good to great journey with Jim Collins. We have a history of growing together. We traveled together around the country building semiconductor fabrication facilities and biotech facilities. And on every a big job, we were side by side with Rosenthal. So we all have sort of a history of working together. Our leadership teams know each other very well. We've all done design build together at scale for time, and we've all done IPD together. And one might argue collectively we may have as much as anyone else in the business. So there's already a climate. If you can understand that climate, you have three organizations who are interdependent and have spent a lot of their life building their companies together.
Yeah, I think that collaboration is really, I think it's in the blood and the culture of our companies. So it makes impossible, what seems impossible projects, not that difficult to embark on, because it's part of our culture to say is, you know what, I know I can't do this myself, but I know with the right partners we can. So we're going to jump into a little bit of a case study on this Crusoe Energy project in Abilene, Texas. If you're scratching your head, or if you're on the map looking for Abilene right now, it's about 3 hours west of Dallas-Fort Worth Metroplex. Heavily involved in like the oil and gas industry, over the years. This project is there's a lot of unique factors, like Victor was saying. Like everyone says, like every data center is the same, but it's different. And then the difference, you end up with like a bullet point, a sub-bullet point, and then you have a list of 100 differences. They're not the same. Everyone coming together is unique for the first time. There's a few things that we set out really from the beginning is, 3 times the speed from traditional projects. So in order for us to have relevance in the industry, we had to deliver something in what looked like a maniacal timeline. And everyone, you go through the different stages of grief. We certainly started off with the grief of like, you want what? And you want what in 10 months was the first, I think it took us all probably a few weeks to digest that and then take it back to our collective organizations to convince them. And we had some other things like around, if we're going to do this, we know we have to have industrialized approach. Like that was a no-brainer. We have to maximize that. It wasn't even a decision. It was, we're doing it. The collaborative partners. We knew we had to have the right partners in order to deliver this. We weren't going to go out and do any RFIs or RFQs to force people to respond to it. Like we knew who the best was and we were going to bring them on board. And if they couldn't do it, we're going to go find the next best. The next is the cultural shift for speed. One of the things that we had was I'm going to flip to the next one to give you a sense. This was when we first mobilized in July of 2024. But we shifted for speed. It was, if the hyperscalers delivering data center projects are absolutely brilliant. Like the last 10 years, they have been optimizing and squeezing. They've built programs and prototypes. They've done offsite construction. They've changed their companies. They've done a fantastic job. There's no doubt about that. They spent decades building that. We had about 12 hours to put together a plan. And I'm not kidding. I'm going to fast forward here, to where we're at. As it gets through, currently we're in January of 2026. We have over 4 million square feet of data center and over 600 megawatts, that's, being built and being tested right now, which was, the speed was, like I said, it was about 3 times the speed. And not just the construction, it included the design piece. Like this next slide here this is the end of March 2024, meeting number 1, sitting in San Francisco, going through the mission of what we were going to set out to go do. And we started designing that day on that whiteboard and put together not only the priorities of the project, but we put together how we're actually going to do it. And the stakeholders started working on it immediately. The first, the culture. I think we knew that in order to do this, we had to have one team aligning each other's cultures. It didn't matter what DPR, what Rosendin, what Southland wanted. It didn't matter what Crusoe Energy wanted. It was like what was best for the project. The readiness-based decisions, we're not a bureaucracy. Like, we need real-time decisions in order for us to meet it. Like, if you're not in the room, someone's gonna make the decision for you. So like, that's how we operated. And I think it really started to change people's mindsets. And in order to do all that, you have to have trust. And like, trust is a really sticky subject for a lot of people, because however many of us are in the room, we define it all differently. Whether we base it on trust as your experience, your competency, how much you care about one another, it is a sticky thing. But we knew we all had to lead with it. So that was the easiest part, is knowing that we had to trust. And we're gonna get into some of the technical stuff here. Simon's gonna talk about a little bit of the application of DFMA.
All right. All right, so to provide a little bit more color to it, I mean, I still remember I was on the floor. It was like a Friday night, 7:30, playing with my kids, and I got a phone call from a 415 area code, and it was like, and it was customer saying, "Hey, we're getting the team back together," and I was like, I think you got the wrong number. Like, it was like a big distraction. And then even, the next week we had this first meeting, and there's a group text of all of us going, "Not a chance." Like, it was like a laughable kickoff. The project even was nicknamed Ludicrous because, one, because it was kind of a crazy theory. Two, because if you've seen Spaceballs, you have to hit ludicrous speed, right? So there was a lot of really cool things that were happening. But at the time, we were still looking at lead times on equipment that were 50, 60 weeks, some things up to 80 weeks, and we were supposed to turn over data halls in less time. So it went against everything that we knew at the moment, as far as how do you buy things, how do you build things. It wasn't possible in the first meeting, and we started breaking it down into very, very, very simple components. And that's kind of where this part starts, which is the concept of minimum viable product. So, when we started getting into it, it was, how do you break it into components that could be easily sourced? How do you get to the point where I always call it like a Home Depot model. So if I can't buy it at Home Depot, I probably shouldn't design it into my project. And to think that that's the application of building a 1.2 gigawatt data center campus that's supposed to be the tip of the spear of this huge Stargate initiative, it's actually kind of terrifying as I say it, but that was it. Is you had to get down to like, what was the bare minimum we could do? Is how vanilla could we get a design? And that's the technology, the topology, the infrastructure on the systems, and then into the building. So how vanilla can we get it? And then what options could we give them as far as sprinkles? Do you want chocolate sprinkles? You want rainbow sprinkles? We don't do marshmallows, right? So it has to be really, really plain and vanilla. That also is a way that you start to control cost, right? So you narrow the supply chain, you focus on those key elements in the process. And I remember one of the first things we did electrically was just say, how many breakers do we need to buy? We don't even have a vendor, but how many breakers do we need to buy? Let's go buy breakers. And that was it. And we just did them, and then we drove that. And so as we went through there, we started looking at critical path and what different items we had to do. One of the big driving factors was building steel. So we made the decision to go with a pre-engineered metal building, but that meant we had to make commitments right away. So you're sitting in a design meeting, you don't have a single line, you don't have mechanical systems, you don't know how you're going to cool it, and you've got to commit to column spacing and square footage and these huge, huge decisions that cost millions of dollars that'll be carried over. As you can see, I think we're 8 buildings in now. Mm-hmm. So 8 buildings in. So we made these decisions, in a couple days that have impacted the last 2 years. And so you tie into column spacing, and then you start working through the blocks. And so you really started with the system blocks and then just tied in and made commitments and did it. You find a lot of inefficiencies, which I think comes up later. But from a speed perspective, it allowed us to do something we had never done. And I think, so we kicked off design somewhere in April. We were already delivering electrical infrastructure to the site by October. So in less time than it was taking to procure equipment, we were buying it, receiving it, installing, integrating, testing, and having it on site. So it's something that was just kind of, maybe if you backed up 5 years ago and you wanted one skid, that was fine. But to put context too, it's 192 units delivered, to do that one significant block. So nothing like you were talking about. Your numbers were very cool, but for us, that was big infrastructure. It was something that we hadn't done any before. So now you have to start mobilizing facilities and things too. So there was a lot of stuff that came with it. we all sat down and we really went through the systems, and that's where you kind of get through. So like after you really dumb it down and say, how basic can we get it? Now, how do we start building your components and blocks? And that's where you get into the DFMA. So it's saying, hey, logistically, what do we need to do? What's the move in, move out plan? What kind of boom do we need on our cranes? How are we going to do it logistically with the site, in sequence of install? Are there going to be generators in the way? Do we need to load everything from the left? Is it southwest? Are we going to impede other installation? Like we can't be installing electrical skids while they're installing chillers. So as you start building the building blocks, then it just becomes a big kit of parts. So we started doing with the multi-trade racks and other products, and everybody started carving it up. And one of the other unique things here is nobody was very selfish in the moment because everybody played their part. And so it was like, you take this, we'll do that. The swim lanes were very well defined and everybody just ran the race together. So it was a pretty interesting thing. And then, the plan, because we knew going in, is it had to be something that was very repeatable. So not only are you setting up a supply chain to deliver day one, you're also setting up a supply chain to deliver this 8 times. So it was a 100 megawatt build, but it was actually 800 megawatts. So we needed to do it 8 times. So you also had to have a design and a plan from a supply chain perspective to do this 8 times over and over again. And the buildings all started to overlap to where it might have been 100 megawatts every 12 weeks, but it was really like 100 megawatts every 4 weeks. And that's what he was saying. When you start looking at how you start turning over the data halls, you were constantly installing, constantly shipping, constantly testing, and constantly commissioning.
I'm gonna double down on one thing you said there. Simon, was like I said, we've gotten really good as an industry at designing and optimizing data centers from an engineering reliability standpoint. We've adapted them for different server or GPU technologies. We've gotten so good at it that we've paralyzed ourselves because we know we can always do better. And like what was interesting, and I think one of the things that we came out and saw is the ability for people to let that perfection go. That was not the mission, is to build a perfect data center. It was not the mission to build the most reliable one ever on the planet. It was speed. Like speed was the most governing factor. And so it changed the mindsets of our engineers to say, I need to get good. And I'm not going to be waited on to get perfect.
Yeah, and that figures into all of the conversations, even the design. Like how do you, I think it was actually on the slide before, I probably didn't touch on it, but like how do you, I talked about the Home Depot approach, but like how well educated can you get at the component level? If you buy things in 10-foot increments, install them in 10-foot increments, like stop cutting things, stop making 9-foot 8s, like make everything whole, get rid of all the waste. Any lost steps are a waste of time. And so what we found is a lot of efficiency in how we did that. Now it can look inefficient at times, but when you actually look at speed, which was our only goal at the time, like we weren't, I'm not going to say it incorrectly, we weren't really given a budget as a target, we were given a deadline. And so you got to make really good decisions. And so with that, there were some decisions that were made that were solely in the purpose on how fast can we build. And a lot of times it's, can you install 10 feet versus can you cut a foot off and then install it? And that wasted time, we look at the waste of materials, but that time and that waste was something that was very, very critical in the design decisions that we were making early on. And with this, like I said, I kind of already touched on it. It was this, the early collaboration. So they didn't wait, they didn't go off, they didn't have a 2-year design charrette where we tried to create the perfect plan. It was sit in the meeting, pencil out on a whiteboard, everybody go home, populate the model by Friday. I mean, it was pretty much just like that. And so everybody had their part. And so you had the modular integrators, so you had the big systems people, you had the architects, and everybody was working in parallel. So there was no traditional sequence where you get this and then that. So nothing happened sequentially. Everything was in parallel. So you kind of opened it up, put it around. They're putting columns around skids. They're building roofs, adjusting the heights and everything. And so having all of it, and I think you talk on contracts, right?
Yeah.
So, and then the other big key with it is having every partner involved in every conversation. And so everybody had their role. So we were doing coordination before even the decisions were made. It was like, hey, stay over 12 feet, we'll stay under 12 feet. So even in your swim lanes, you're already creating out these windows volumetrically from a planning perspective so that when the other person was working without your information, they had, spatially already claimed things within the building. And then it was just double down. It's how much can you take off site? Knowing that you're in a place where the population at the time was not like 60,000,
60,000.
60,000 with a small airport. And we currently have 4,000. How many?
No, we're over 9,000 people on site.
Maybe we have that.
Yeah.
So there's 9,000 people on site right now. And so when you look at that, there wasn't a lot of confidence that we would ever get to that labor force on site. And so the whole entire plan was, what can we take off site? How far can we get it? We selfishly had the benefit, us and Southland, of having facilities in DFW, so we're only 3 hours away. But to mobilize that many electricians, that many welders, to get all those people on site, I mean, it was a major task. And so it was like, hey, how much can we productize? And then going back even through the process, and then how much can we improve that productization to remove more and more hours?
So I think the other, when you look at the contracting, all four companies knew each other pretty well, the owner. And the owner chose to go with 3 design-build contracts, multi-primes, and DPR was the coordinator amongst the 3 of us. And the thing that really matters is our design company is probably the 15th to 18th largest in the country. So when you look at companies, do they have in-house design staff? Because they understand how to get things done. If you've got new people who've never designed this stuff, they don't understand how to design it so you can actually make it in the factory and then take it forward. And then if you have people who work together, we also have to figure out, if I can go at 10,000 feet a day, and you can go at 12,000 feet a day, and you can go at 20,000 feet a day, I better catch up. So we have to design our systems so we have the same beat, the same tact all the way through the job. It's of no value for someone to finish early, right? You all got to be there together.
Yeah, I think just I'll be there together. I was one of the designers for under DPR is GPLA Structural Engineers. I think he left the room here earlier, but that picture that I had of us all in the room in March, we had full mill order steel out by 4 weeks from there. So we had design and mill ordered steel and ready to start fabricating, and steel started in August of 2024. So within 4 months after start, steel was on site, fully designed, everything. The contingency planning. So I just sharing a little bit about myself. I'm like, people joke that I'm the conservative one. I'm the one that's probably first to say is like, okay, let's be responsible here. Like, let's not be wild cowboys. So I get a lot of flack for that, and like that's fine. I've learned to be really uncomfortable in taking on challenges that I have no idea exactly how it's going to go. But contingency planning, like we knew that we were going to run into problems. Like anybody here can tell me, well, what did you think of this? Did you think of that? It's like, yep, we thought of it. And you can try to engineer strategies around it, and it is going to happen. And it happened every day that we had challenges. So like the way that you do it is we talk about like what are the things that we should assume this is going to happen. Okay, let's work this into the design. We should assume this is going to happen, so let's work it into the commissioning plan because it's going to happen. And it doesn't work very well when you have partners that want everything perfect so they can be productive. Like you have to be adaptive in what you're doing. So there's a little bit of a call to action in our industry is like, scaling the delivery across all systems. Like we have to be able to do this different. And then,
Sure.
Paradigm shift, who's that?
is that me?
Yeah,
Okay.
that's you, John.
Yeah, I'm sorry, guys. There's
We try to take
shuffling
turns.
some
We
slides.
probably work too hard on
So-
taking turns.
I think the paradigm shift in the data center construction is really like thinking differently. The productization is we're doing it. Like all of our competitors, all the hyperscalers are doing it. It's just it's a bespoke process right now where it's typically done in a silo, and it's like, here you go, versus let's engineer it together in a sense. The ecosystems I think that we were really talking about is for all of us really to be working in real time. What Victor was saying on the contracts, I think we didn't really all know how much of a difference it would make by having responsibility for design and construction and the modularization side and the installation of it. Like having those all like in-house and in control of that really proved to be a big difference maker for us, where you don't really see that. We're not like the way the trades and our companies, Like we're not all wired that way across the US and certainly not around the world where we're fully capable of doing all of those ourselves.
So
like that's a change.
One of the things we also got to look at is traditionally I have to worry about my work, but I have to now sit down and say, how do I make life better for him because I was there, and how do I make life better for him because I was there? That's a different responsibility. And sometimes, we talk about pipes and pumps and sheet metal and everything. We don't think about what's the implication for the structure and for the electrical. And that's a little bit of a difference. And you've got to continue to remind people, particularly when you get under pressure, because you go back to what you were promoted for, which is optimizing your piece. And there was a lot of pressure on this stuff.
Yeah.
And then I think I'll touch before you go forward. What was interesting because John talked about it, and it's we were talking about how to get to vanilla, right? How do you get it real simple, and then the concept of being bespoke. So we build for I think 26 different data center customers, and we do not have a single customer that has the same product. So like we don't have a go-to-market or anything. So it's the exact opposite of what you want in manufacturing, right? Everything is batch manufacturing. Everything is made to order. Every single customer has it. But with a big push into the industrialization, the standardization of what we did, we said, hey, we can really guide 80% of that towards knowns. So we could predict the schedule, we could predict the cost, all the things that became very important over time. Initially it was just, is it possible? And day two was, is it possible giving the other things? I think we produced a document at the end of last year, and it was a little celebratory thing. I should send it over to you guys. But it was, we delivered 672 skids. We had 17 schedule changes in the first year. So 17 delivery and schedule changes, and even the product had to be designed around. So all of the products have to be designed around the fact that the equipment's not going to be there, or it is, or maybe it is, or maybe it's not, or maybe they switch the equipment because somebody else could get it there faster. And so you had to have these very agnostic designs that were very simple to work out a sequence. And how do you build out a sequence? And how do you not have critical path items that in the data center world we've just kind of accepted it, so it's not real stressful. Like it's very stressful outside of data centers, but when the equipment's 2 weeks late and you can't do it because you can't have millions of square feet of product just sitting work in progress, how do you keep the machine rolling at all times? And so, what we did is we were able to put all these designs and concepts into play that allowed us to have the late equipment, to have the shifts in the schedule without impacting, any of our deliveries. So we were still able to do stuff, or, in the midst of it, work with the site teams because they were having delays to not affect critical path. It was like, hey, let's hold this one back. Let's prioritize that. Let's shift things around. So it was a very dynamic thing. It's the exact opposite of what you want. But it was tremendously successful. And all of that was based on being able to take this productized, industrialized approach.
I think what's interesting is like the benefits of DFMA. It's like we just scratched the surface. Like we were able to achieve the speed, and we just scratched the surface. I'd listened to I don't know if Ernesto and Andrea are still in, and like the planning of their projects that they had on site was amazing. And like if we could achieve this, and then but have the certainty of DFMA and to really fully adapt, like wow, I think that's going to change.
I think the next one is really the risks of failure. I'll come back to two simple rules. Number one, you can't make a good deal with a bad person. I don't care what contract you sign. Anyone can break any contract, and anyone can screw anyone else they want to. It's very easy. We've been trained to do this. But number one, if you've got good people that you can shake hands with and you have time working together, it's very hard to fail because we are interdependent on so many other pieces of work. And the second one is, if we don't know each other, we're playing not to lose. You put liquidated damages in, you're playing not to lose. Right? We have to play to win. That means you put $1 out there as an incentive. I don't care if it's $1. Everyone's going to try to get that. That's just who we are in this game, right? So if you put something out there where there's a prize, people want to win. It doesn't matter what the size is. But you've got to create that environment. What's the win? And the win in this is, if we can deliver this company has a business proposition, and that business is going to grow quicker than the other ones who aren't playing like this.
Yeah, and then I think, with the outcome, the other thing that we really, really looked at, and I'd have to, you guys might have a little bit of data from yours, but when you start looking at the scale of the projects, what we were delivering, and the amount of people on site, people kind of forget the effort that takes on off-site, right? And so through the process, we've actually shifted. I think we ended up with, at one point, close to 550 people off-site dedicated to this program, running almost 700,000 square feet of facilities just to hit the cadence for one single job. Now you add in what Southland had in their facilities and the scale you've had to do. In order to support a site that's moving this fast, that has all these restrictions, that has all these problems, and the ice and snow stuff that just happened, it's really, really allowed us to do that at a massive, massive scale. And so now we can turn things over. I mean, we're still in the process of turning complete data halls over every single month. So 25, 50 megawatt data halls every month. And that's just a constant cadence of things that are going in. And so the scale that we're being able to achieve right now, and then you start overlapping, multiple sites and multiple programs, it wouldn't be possible without this approach.
So a couple of lessons learned. We were just like, what are some of the things? Number one, I think, is scaling from a project to a program. When you look at one project, there's a finite end time. When you look at a program, there's a life tomorrow. And you need to start thinking, how do I do it better? And I think you were talking about, if we just moved the column spacing 2 feet longer, we could have saved half the modules, right?
Yep.
So you learn that. Next time you sit there, okay, there's money. Trade partners become design, trade, and modular partners. Now, if you're a trade partner, you look at everything in the system. So if you've got running liquid to the chip, people may make different modules, but the water's got to go through the same pipe. So how do I know the integrity of the pipe is consistent all the way through? But if I'm building a module, I got to build the structure, I got to put the pieces inside, and I got to do the electrical, mechanical, and other things. So you're playing two roles, and it's not simple. You've got to actively work with each other to make sure we're not stepping on each other's toes. Materials and processes, repeatability of modules, balanced with the evolution of design, and then supply chain and commissioning. And I think there's other things, maybe it.
If you guys want me to talk more, I'll get it. So, Jared, you skip ahead?
Yeah, I did. I think we're running.
John's skipping me.
Time.
All right.
I think there's it kind of goes in the vein of we've got to be able to change the mindsets. We set the goal out of speed, and because of our competitive nature and the way we think is like, we've got to do better next time. We've got to build it for less. We're gonna have to do it faster. Like, that's the expectation that people change, right? And if we don't do that, like, we should expect production to continue to decline because we're gonna resort back to old behaviors. Like, lumping it all together, like, how do we do this? Like I said at the onset, like, I'm not a professional in industrial construction, professional in getting all the stakeholders aligned to deliver on a common mission. And this is that. Like, this is getting the stakeholders. We set out with an owner that really had the courage to define the priorities. I think a lot of times we get ourselves, at the mercy of, there's different stakeholders and all of those have a voice, and you don't really know what the loudest voice is. And so you don't make decisions on priority. You make decisions on whoever you're talking to with the loudest voice that day. And that is a recipe for disappointment. The next is the designers. Like, when the designers really understand that, like, they're working in real time with all the partners that are on the manufacturing side, with the material providers. They're looking at, like Simon said, like, what's actually available. And those design teams, like, they're now changed their expectations of, like, how they do their job. They now know what to ask the question versus design it and expect somebody to do it. They know to go to the provider of it and ask, will this work for you? And that doesn't take but a minute. And I think that's changing the expectation. The builders, the integration mindset is like, understand, what's in front of you and what's behind you. And if you don't know that, then you're probably going to be behind, because you have to watch it, because that change happens constantly. The trade partners, there's one thing around data. Like, everybody wants it, needs it. They want real-time information. That is something that we have to be accustomed to be using, and develop the systems. We watched, like, the presentations today had several different systems to convey that. Like, that's the expectation from every single trade partner right now. The last is the tech and data teams. I think, I cannot be more complimentary of some of the owners that we've worked for. Like, they are trying to break record speeds and design things that have never been done before at size and scale that has never been achieved. And they have to be courageous and adaptable as well, and like how those systems come online. So like changing an owner's mindset to be able to get on board with the whole delivery of the project. Like, it's not just construction, like that's something that shows up on the day that it's supposed to be. It's actually, it takes the integration all the way, from the beginning. So that's really most of our presentation. Going to end on, there's a story. I saw this a few months ago, and someone was doing a little bit of an outlook for 2026, and what the expectation is. So, does anybody know the Roger Bannister story of the 4-minute mile? There's a few head nods in here. So a little over 100 years ago, before the record, back in 1855, when more competitive running became popular as a sport, and yes, I know it started before 1855. This is when it started becoming a little bit more popular in England, and they started timing it with wheel timers and tracking it. And nobody believed at the time they could actually break a 4-minute mile. Like, there was, outlandish, like the human body will completely break down, the heart will explode, and we won't be able to, it's not happening. We're not doing it. And finally it happened in 1954. Broke the 4-minute mile by 3:59. I think it was it 40, like 46 days later, he's got beat again, right? And then after that, it kind of got beat again and again. And where we're at today, I think we're below 3:43. Is because it kind of changed the expectations, which was really a theme of what we were trying to get through today, is change the expectations of collaboration, and you can have the outcomes that you set out to be from the beginning. So thank you for that. I don't know if we have time for questions.
Time for questions? All right, do we get to sit up here now? All right. Now we get the fun part.
The shooting targets here. All right. Well, thanks. I thoroughly enjoyed that. Yeah, I mean, in the trenches examples and stories, and then the reflections. So I'll also be curious how that resonates with you guys. I wanted to start with a couple questions, and then, give everybody here also opportunity to ask some questions. As I reflected on your presentation and also throughout the day, I think what we have seen is in every single case, project teams, people in companies, engineers, managers, and so on, showing or having developed different behaviors of how you act, what's normal compared to what's sadly normal on most projects. And I'm just curious if you can reflect on what are like some key behaviors internally to each of your organizations, and then also maybe some behaviors of some of Crusoe, client, of others. What are some of the really key behaviors that you found were particularly important to have or to develop or to watch out for when you brought people on board? I imagine you look for these kinds of things now. Mm-hmm. I think that would be quite helpful to hear.
You want me to go first on this?
Yeah, go ahead.
I'm gonna say I got a lot of home base here in this area, so I got to be careful what I say. So what ironically, we're two separate businesses within a holding company, and so historically we don't always play really well. We're like siblings, and so sometimes it's sweet and we hug, but we fight frequently. And so this was like a really big dynamic shift in the holding company approach to doing work, where the manufacturing kind of took the lead on how we were going to put and integrate into the system design. It was driving decisions because Rosanen owned the electrical contracting portion, we owned the electrical engineering, we owned the manufacturing. but it was really MPS led. So it was really the first time that manufacturing led the way in making a lot of decisions, and even engineering and the construction teams, I'm not gonna say they took a back seat, but they had an open mind to the changes that we needed to make it viable. And so sometimes that was changes to your system topology, the electrical, like the actual functioning of the systems and how it needed to be built and the layouts of the rooms and everything. So for us, it was like a huge wake-up call, and we found that it's tremendously successful, and it's actually the model that we're using moving forward. So we had an accidental project where we had this, like I said, you grow more out of necessity than you ever do out of planning. That we found that like moving forward, the strategy in every vertical market is actually manufacturing. So even though we've been data center focused and everything, now every market vertical is saying, hey, we should lead with manufacturing in semiconductors, in energy, in every single market that we're doing. So it was a very, very positive outcome for a company that's, nearing the $10 billion of revenue mark. So pretty significant outcome that was accidental. Yeah. On the good side.
You even already answered my follow-up question. So it's,
Martin, I'm gonna chime in about Crusoe Energy. A newer company, really on the block, and I think they really set the tone of the project and the expectations from the beginning in a way that I've never seen before. I've had the luxury, working with you, Martin, and Howard, if you're still in the audience here, on a first IPD data center project, and so I had some of my some groundwork laid of what I expected a high performing team to do, but I've never actually seen a customer do all the shit that we say we should do. And excuse my language, I've seen customers, they talk a good talk, but they don't follow through. They've got some governance, they've got something that holds them back. And that was not Crusoe. They set out the expectations from the beginning. And that transpired right through all three of us, up to the leadership of our companies, to our trade partners, and then down to the local municipality. And so it was contagious. And that has proved to me that there's a different way of delivering a project. And I think it can be done at any scale, big or small.
Yeah, I think it came down to the owner. When they started this job, they had 123 people in the company. A year later, they got 1,000. The culture's changing. But that first meeting with Jamie and the crew, when we understood that their business depended on us to do this, and they were straightforward, and they said, you guys are going to do it. And they said, if you need something and we can't make a decision, go right here. They trusted the people on the team to figure it out, and they said, go. And I think they expected us to become an extension of their company, which is a hell of a trust. I think the second piece is there's a phase 2 to this stuff, and they're saying, hey, we got to go now, and we got a bunch more of this. We got to keep going. So we're having to take in our organization, usually our manufacturing, we have 12 to 14 manufacturing, keep adding them, I don't know. It's about 3 million square feet around the country. And they're saying to us, okay, now we need to look at this across the organization and pull that together. It used to belong to the business units. Now the Modular Solutions Group, and I think we've learned from Rosendin, that makes a lot of sense. What are we going to make where, and how do we stand up factories quickly? So this, after you get the lease, we want the facility up and running in 2 months, fully tooled and everything. So you got to get your supply chain on your tooling. And for us, we manufacture a lot. Usually 20 to 25% of our work we make. It's the piping, it's the welding and all that. And then we take it to the modules. So when we've got the modular 2, it's about half our work. And I think we didn't manufacture as much as we could have in the first phase. But on the second phase, the team has developed a matrix of, we've done this, we do this, we're implementing this on this job, this one. We're not doing these ones, we're doing this one. And so it's each subsequent facility, and there's a plan on how to implement which things, which tells you there's a tomorrow. So if you think you're good, you're wrong.
Yeah. No, thanks for that. Simon, you already alluded a little bit to that. I was also curious, what were the most significant internal barriers you had to face? This is all happening while the rest of the company is not exactly idle. to my knowledge. It's big competition for resources in all kinds of areas, attention for all kinds of things, from innovation to resource needs. And I can think of many more things. But I was just curious, what were some of the most significant internal barriers you had to overcome?
I'll focus better this one.
Okay, go ahead.
Ours was unique because we had to pool a lot of resources. Traditionally, we're 100 plus years old and it's very risk adverse. We're employee owned, right? And so all of us hold equity in the company, and there's a lot of people that get to have an opinion. And so the company's been very risk adverse. And so to bring in projects like this that have large amounts of revenue and a perception of risk was something that was an internal hurdle. So there was the teams on the EC side that really had to go to bat at the board and convince everyone. I mean, you're dealing with the sureties, you're dealing with bonding, you're dealing with cash. There's a lot of conversations. And in the middle of that, you're trying to run a company that already is existing. You're trying to make payroll, you're trying to do these things. And, to do these projects condensed, it also condenses the cash flow. It condenses a lot of things that are very important. And so internally, there was a lot of just pushback on, we shouldn't do this. This is too much. It's too risky. We shouldn't go all in. We need to stay the course. This doesn't support our geo model. And that's just from being a very old and mature company. Mature is probably better than old. Mature company that has been just traditionally very risk adverse.
You want to?
Yeah, I think we've spent a bit of time working on a one company solution. And one of the rules is, we have 3 rules in the company, our strategies: develop your owner, enable your partner, act as one company. And act as one company means you bring whatever you can to the work phase to solve the issues. So on the construction teams, I think we were in pretty decent shape. It was the manufacturing side where we used to make, each business unit make stuff for themselves. And now you want me to send it somewhere else? That was a little bit foreign. And I think the business unit that headed it up, fortunately, they're a very can-do group. I mean, it's cowboy country, and let's go. We make a decision, and they go. I mean, I don't know how else to say it. There's a tremendous amount of trust there, but the difficulty for us was the manufacturing, and we're still working on it. I mean, it's going to take a while.
I think for us, it was, watching the presentations this morning and seeing the founders of companies, the CEOs of companies, COOs, what you all are doing, takes a lot. You're trying to change an industry and you're trying to run a business at the same time. We were, for DPR construction, we were at a point to where, we were at a healthy spot, but we were, confronted with commoditization. We were no longer bringing full value to data center construction because people figured it out. They got the systems in place, and it's going to be the same old every time. So we needed to make a pivot on what we actually deliver and who we deliver it with on the next frontier of data center construction at the size and scale we did. And so for us, it was we had to make that decision. But we still had to convince a lot of people of the reasons why, because they're not, a part of it every day.
Prince, or is this the beginning? All right. I wanted to go to your final statement. Automate, integrate, what was the first one? Productize?
Commoditize, yeah.
Yeah, productize, automate, integrate. So on this project, obviously you advanced this quite a lot. And I realize we haven't really developed, formal scales, what this means, but I'm just curious, what grade would you give yourselves along these 3? Just to get a sense of let's say even on a scale from 1 to 5, with 5 being what we
I
could
think
imagine.
we actually talked about it. It wasn't 1 to 5, it was like a B-.
Yeah.
Yeah.
So, we're passing.
Yeah.
But we can
So
do a
you
lot
would
better.
give yourself on this project something like a B- in
I think we
these?
don't suck,
Yeah.
right? We suck less than we used to, but we aren't good yet.
Yeah, no, I mean, I'm
We
just
have
curious
to get to good.
for us to calibrate where you think we are relative to where we should be or could be, or
Yeah, my presentation to the board was we are the most okayest in the industry right now, and which speaks a lot into where the industry is and how behind we are. I had the benefit of spending a couple of years doing international modular, working for a company in England, and so I kind of got a taste 10 years ago of what we could do 10 years ago, and we're still not there today here. So it's almost embarrassing to sit in an international conversation and watch how advanced everyone else is to where we are now. What these projects are driving the conversation is to really get us there. I mean, part of the reason is there was never enough scale behind the manufacturing to get to the numbers to work out. And anybody who understands manufacturing, you have to have volume, right? So until you hit these critical thresholds of volume, there's no money to be made. And that's why so many companies were going out of business and stuff. And all the press in America was around the Cateros and all these big companies are setting up factories and going out of business. And we're, working in a tool shed, just kind of like sending stuff down the road. And so what this has done is it's really given us the ability to really push that product in, and we can hit price points and stuff. I think, if we had to grade ourselves on this project, we could have done better. However, when you look at, did we hit the mark? We nailed it, right? And we accomplished the goal. Now, did you accomplish the overall mission of the industry and what we're trying to do even on the future phases? No. And so that's where a lot of the rework and the stuff that we're doing recalibration and development of new tools and products, if you will, is what we're doing moving forward.
I think the discipline John has brought to us, though, is you can't innovate on everything. So what is the most valuable on this next building, on the next building, and the next building? If you change everything, you can't learn. Yeah. So do one thing, get it right. Do the next thing, get it right. And so I think we're trying to drive in that direction. But, we probably should cut the time in half again. If you want to innovate, you say cut it 10%. Okay, what are we going to do? We're going to work double shift, we're going to try harder. We don't do anything different. But you're going to make a crisis out of it. So if you've only got a month to deliver this damn thing, how are you going to do it? Yep. Then you've got an oil field in Alaska where you just truck the whole modules in and set them in place.
Yep.
But the economics have got to make sense. So you have to create the crisis, but you can't have too many crises or your people won't last. Right? You've got to make the crisis real.
So let's see from the audience. And briefly introduce yourself. And
Hi there. So one of the things that struck me immediately is...
For those that were not here earlier, Ray Levitt, former Stanford Black mentor.
Original director of CIFE. But the...
COG.
If I can claim that, Morton. Yeah, no, definitely. So what strikes me about this is there's got to be a lot more money paid by the client up front. Did they finance the mill order, so 4 months out? Did they finance your purchasing for manufacturing of everything you had to buy ahead and so on? Or did you have to deal with that internally?
That is a great question, Ray. Question and a statement, I guess I'm taking it as. That falls in the B- category as well, right? But I think, yes, we did have some upfront financing. Yes, we did have a customer and an end user that understands there has to be a cash flow that needs to be maintained. And so we did have advance payments and deposits, which was, I think, again, changing the expectations of what it takes to deliver on a scale like this.
That's on the construction side too, right?
Construction and the equipment.
Yep.
and the modules, like all of it took upfront financing, which we've got to get better at each time because we're not far enough. Like when we showed the picture of starting design in March, and construction started the end of March, and construction started in June. Like we needed to be building Simon's modules and Victor's modules for the MEP systems like that day. Yeah, which means we need financing in place to spend and commit to that day. So changing, I think the lenders and their performas to understand that. Like I was going through the audience list. Do we have any banks in the room today? Well, I think that's maybe a little bit of an opportunity for the future because that's a missing component of a lot of the presentations from this morning. Is how do we finance that up front?
Yeah, to put context, how much do you think, monthly burn are we doing on that site?
It's below $1 billion, but it's more than 500 million a week.
a week.
Oh, sorry, a month.
Okay.
Sorry. Yeah.
To your,
Sorry.
so it's not insignificant from a cash perspective.
Hi, my name is Matthew Aitchison, and I'm from Australia, Building 4.0 CRC. I've got a kind of dumb question, but actually the conversation here is sort of rolling into it. And the question is it insanely lucrative to do what you're doing? Because I kind of wonder why you intelligent, highly capable guys bite off this thing to chew. Is there any way to measure how lucrative it is relative to other asset classes and things that you could be doing with your time?
Matthew's in like lucrative
we have
from
customers in the room, so.
from a profit margin as a company.
Yep.
So I think that's where everyone's going to look at profit margin differently of like what's important to you. Like each one of our businesses operates differently. Yes, we have a margin. We all want to make money. We're not doing it for free. But we're looking for, that general blend of like what's going to get us out in front and create a differentiator so we can have the next 5 years of customers that want what we have. And like this project and this commitment was going to be able to provide that for us.
Well,
No matter what the margin was.
Yeah, and on the manufacturing side, once again, I mean, you have fixed costs and variable costs. And so if I have zero revenue, I have a fixed cost. And so that's where the manufacturing side is much, much different. At some point, I have to pay my bills to keep the lights on regardless. And so anytime you have the ability to push more volume through a fixed cost, then profit goes up. So, right, so you have it, you kind of perform at the GP side, but your net profit is there because you're taking your fixed overhead and applying it over more revenue. So from a net income perspective, it's a really good thing to push hard. We'll call it sweating the shops or sweating factories. That's why people work second and third shifts and stuff, so they don't have to have more of a capital investment. But in just in general, what it allows you to do is allows you to hit better cost points, which allows you to keep more of your money. So it's really achieving a lower cost versus a higher margin.
I'm going to expand on it, Matthew, just a little bit. It really fed our businesses. For DPR, one of the things that we want to be is a builder at heart. Like we want to build, right? That's why we self-perform, because like that's important to us. And back in 2018, we were looking to change the strategy of the company to be in control of our destiny. And we wanted to have control of design, and we want to have control of our workforce. And so this customer was allowing us to do, we were engaged in the design. We were engaged with the self-performing capabilities of all of our companies. So we were able to do that, which like that's what we think we can drive value. If we're part of a commoditized delivery, it's like we can't bring that value to the customer. That made it an easy decision.
I mean, the big thing for us was we can't bet our company on a job. But we'll take any damn risk in the world, provided we don't have to bet the company. And I think that's just part of our DNA and these guys too. So when you explain that to the owner and say, okay, we're going to take these risks off the table for you, now we're all playing to win. But if we had traditional risks in this thing, I think it would have been more difficult to do. Does that make sense?
Thanks, Seth.
Yeah.
Thanks, Seth. Good.
Hi, everyone. This is Simge Girgin, previously a recent graduate from a PhD from CIFE and currently with DPR Construction. Thank you so much for the insightful and also transparent presentation. It's really clear how the companies were working together also from the presentation. I have a couple of, maybe one critical question on the improvement opportunities that you saw. You mentioned that it wasn't enough only to improve at the one company level because you've been collaborating very frequently and you needed to arrive at certain milestones together. So one question I have between different phases, like phase 1, phase 2, 3, which type of data you were collecting consistently to inform the future phases and determine improvement opportunities, both on the electrical side, plumbing side, and also drywall. So really high level, how you were collaborating both horizontally at the leadership level, but also vertically on the frontline workers to keep this improvement for the future phases.
I'll tell you the big thing for me is how many pieces. All right, it's about $30 to join two things together in our business. So how many pieces do we have in the module? And how do I get rid of the pieces? Which means making better connections. That's the data you need. All the other stuff is nice, but it doesn't really matter, right? So how do we minimize the number of pieces in a module? And how do we create workarounds for the tolerances? Because, you know, when we bring things into the field, these things don't fit. So how are we going to solve that? And how do we connect with the fewest number of connectors?
I was going to add, I think there's the obvious ones that I think, you know, everybody would expect when you got repeatable opportunities of constructing a similar building. You'd expect the number of work hours to go down. You'd expect the number of people on site to go down. You would expect the number, Simon said 17 scheduled changes, that to go down. So I think it's like all of that segment, like there's a cadre of things, but like that's why we give ourselves a B-, you know, on it. It's like there's lots of room for improvement.
Yeah, I think the schedule is still at a pace that doesn't necessarily encourage improvement. Awkwardly enough, like you're almost too busy to get better. You can't take a break, you can't take a day off. We can't, you know, you're 2 or 3 buildings ahead and you're saying, hey, we can make these changes. They're like, hey, we bought that 6 months ago. So like we're stuck with what we bought. So the improvement process isn't there. I think it's more of a refinement. So it's understanding the volumes that we can push through, the man hours associated with it, the head counts we could do on site. And so it's really the improvement in the overall schedule and the de-risking, right? So predictability is maybe one of the most essential parts of this, right? So if you can take all the ambiguity and the risk associated with early and late and this and that, and you can just refine that down to something that your customer can use, right? Because at the end of the day, you're trying to give your customer the tools to go get another lease or to sign a new customer or to make a better agreement. That's really the data that we use, was just a refinement on, you know, how far can we compress it? How certain can we be that day 43 will be day 43 and not 64? And that's where we did, because there wasn't a lot of opportunity to improve the product, right? If you can live within your box, you can, but columns were set, foundations were set, underground was in. There, you know, you still have to hit that window, and so there wasn't a lot of flexibility. So a lot of it was process improvement, supply chain improvement, and then refinement of the data, so that you have a more predictable model.
Hi, thanks so much. I'm James Ehrlich, Director of Compassionate Sustainability at Stanford School of Medicine. Flying the ointment question, how are you dealing with pushback from municipalities and local communities with extractive data centers, unfortunately, water consumption, power consumption, emissions? Just curious, thanks.
I think it's a little bit different on each project, but obviously it's a big part of what's in the news. There's a lot of like education of what happens, like so upfront from day one, meeting with economic council from the city of Abilene, so they can help educate their constituents or their citizens, and that like the education piece made it relatively, I think, easy, because we were truthful upfront of like what they could expect from a data center. You know, a lot of times you're worried about the water consumption, so explaining like what we're actually doing. We're developing like closed loop systems. And so there's a lot of antiquation of what, you know, people like I think I hear, are you building a Bitcoin box, you know, and you know, at the time, you know, Crusoe Energy was doing, you know, flare gas mitigation. And so there's a lot of, which was like spectacular, but not at this scale. So the education piece, I think, is what shifted it from the beginning.
Good afternoon, gentlemen. Tomislav Žigo, Bexel. First of all, head down for monumental effort. This is impressive. I have a question. You roughly put almost 20 million hours in that year, or north of 20 million hours. and 9,000 people at the job site means, yeah, you self-performed a lot, but I'm sure there was an influx of labor that first time worked with you. How did that process that you just described alter the culture that was definitely under strain with all the new labor coming in, and how did that process that you described inform your safety culture to deliver projects like this down the road?
I'm gonna jump on that, Thomas, real quick, because like that, I mean, like I said earlier, like I was then astonished by how it transformed from the owner that started the project. It went through us, it went through our organizations, and it immediately went into the field, which like you just don't see that on projects. And like their ability to influence the expectation and the craft workforce, it happened almost from day one. And like capturing that magic in a box is like something that I think that I want to take to the next owner, in front of like our own teams, because the superintendents that were leading the field, they took it to their foreman took it to their craft. The craft that was inviting their friends to come join that project, it proliferated out, and it's one of the best projects that we have on for all of our businesses across the book, even with the demands of the size and scale and the proximity of that location. So I think it had to be done from the beginning to set that tone.
Thank you. Mohammed Al Hussein from University of Alberta, Canada. Thank you for a great presentation. I was excited, the music in my ears, to see the involvement of Modular in such a big scale project. I was part of a study, one of the largest GC in Canada, and top down they said any project will come, we should make it modular. And the lead author has all the minutes, and every project they come, because top down, get excitement goes up and then go back, default to the conventional. What did you do to make it happen, and what advice would you give for those who have such a motivation?
I'll start with this one. What was nice is it started with the owner, right? It wasn't really an option. We always say that necessity is going to drive innovation better than any idea. And so we had such an impossible task. I don't know that there was any other option on this job. And so it was very nice to go in there. The other huge benefit is there is a pretty large mass adoption of offsite manufacturing in data centers currently anyway. It's very expensive. The systems are leading it, electrical being probably the main culprit in excessive cost in all data centers. And so, I think it was there was never a discussion of it being an option. And so we already have a pretty solid, movement into the industry of everybody needs to go this way to hit the scale and volume. But on this job, there was no other play. I mean, like I said, we were installing the skids before all the walls were up. So
It was the only way you could fabricate. Like, I mean, you're fabricating, one step, almost days away from the design model to the fabrication model. We're right on top of each other. There's no other way for us to achieve it without full VDC in fabrication models from day one. Like that hasn't changed. Maybe we've been fortunate. We've never seen the fluctuation of trying to abandon it.
Yeah. And then when you look at, like I said, even in our shop on this program, we worked almost 600,000 hours. So you pull all that off site, and all the struggles to get everybody to site is enough. And then eventually we get into things like cost and safety. And so, the factory is a much safer, more controlled environment. It's also, even though it's a 3-hour drive, it's about half the cost per hour. So you look at the efficiency and the fact that we're using 70, an hour on the site might be, 0.6 hours in the factory, and then we're half the rates. There's also a big cost benefit on that project to do the offsite approach.
I think I'll go back to the last question, why did people show up? People show up on jobs that are, construction is inherently motivating. So if you let people work, they have the materials, they have the tools, they have a safe work site, the job is modeled, the job is planned, and the stuff comes out in order. People want to work on that. And we thought we'd have to throw money at this to attract people. Nothing. I mean, not even close. it was a job that people wanted to be on.
Hi, David Graham, Nova Scotia, Canada. I'm a builder developer who I do my own construction management, self-perform a lot of things, which includes having a formwork company that does that for our company and other companies. The war room that you put together seems like an incredibly impressive thing. So your accomplishment in a short period of time has been outstanding. If you don't mind sharing the following, would you change the architecture of the war room at all to include people who hadn't been included? And you don't have to exclude people, because I wouldn't want you to have to say that necessarily publicly. And are there any things that you did in haste that you couldn't re-engineer without sort of losing either time or money or efficiency along the way?
Ooh, I'm going to make an attempt, David. I'm going to maybe just give a little bit of what we had. Like, if there was an illusion of a war room, it was very short-lived. Like that picture that we had of doing the collaborative, like, whiteboard sessions, like those quickly moved. We were spread across the U.S., in Europe, and in India of stakeholders. It was like almost fully virtually collaborated on all the design from everybody. And that was one of the hardest things to do, is to get the behaviors of the clusters, like the design clusters, to start operating in an efficient manner. Like everyone was really working towards getting the right people to the table. And that didn't happen overnight. It took a couple months to get the right stakeholders together. But once we got those clusters and those work groups going, like it was like seamless. The design management, aspect. We had Alphatech, who wasn't mentioned here. They're local, but Alphatech jumped right in. They put their company, front and center on the design coordination side. DPR, Southland, and Rosendin all managed the design, piece, and it was right there with the schedule. And so, like, the best thing is being able to repeat it and do it again with the same stakeholders. Like, that was the snowflake piece. Is like, you think about the projects that you're a part of, the stakeholders are never the same. Like, you're changing them constantly because of geography, or someone's got a requirement for bidding projects, or you have some other, the timing doesn't work. And so that, like, having the same team play together, it's amazing what you can build.
I think one of the more cool things about it was nobody in the room was a role player, right? So what's interesting, it was a room full of people that 15 years ago were in the room, and so when you look at that, these were not third-year engineers and stuff. These were principals, owners, C-level, E-level kind of. This is an executive suite meeting of people making decisions. So it wasn't like, hey, throw your best, 10-year guy at the job. It was the business leads of every single company that sat in the room. So you had centuries of experience in the room to be able to make the decision, good and bad. You had a little bit of the new flavor. I'm probably more of the new flavor of coming in with the manufacturing and everything. But you had these relationships and long trust, and all these people hold very significant roles. So it wasn't a traditional like design charrette where you send these people. I mean, those people, those all had super titles. Those were very expensive meetings. We'll put it that way.
But they were cheaper than the big meetings that take forever.
Yes. Yeah. We got a lot done.
So we'll do one more question.
Hello, thank you for the presentation. I'm a student here in Stanford and originally from Obayashi company. And Masafumi Fukasawa. And one question, I'm taking the class named Build and Trust this quarter. And I knew that you were talking about really trust in the presentation. How did you really build your trust or cultivate your trust in your team that we never all together work together each? Or do you have some kind of philosophy in yourself? Or
I didn't know there was a class on that. That is
it's a good class.
That is awesome. I think that is that's really intelligent. Whoever decided that, because like I was saying, his trust is different from everybody. Yeah, thank you. I think, Martin, it goes back to everybody talks about it, but nobody wants to address it. And I think developing that trust is like, is trust earned or is trust given? And what end of the spectrum are you on? Because the person next to you is probably not on that same spectrum, and you're tasked with figuring it out. And good luck, right? I think, but the way that, like we said, we had something I think special with our organization and Crusoe Energy and some of the other stakeholders that we haven't mentioned, the other partners. Like it just, it took the vision from the beginning, and then we didn't allow for any distrust to infiltrate the team. And it was like, we have the slogan within DPR is called bullshit. Like it's if you see something that's not right, like that's not a big deal, just say it. Like that doesn't seem right. And then you give the voice to everyone in the room that it doesn't culminate, over weeks and months. And then all the time you got like teams taking their corners. Like that piece is paramount from the beginning. Expect the trust and the trust given back to you.
Yeah, I think you gain a lot of trust and doing very hard things, right? So it's the teams that have been through the trenches, and so all the companies have been through. I'd love to say we've done all exceptional projects, but that's not the case. So years of organizational culture and trust between the organizations. I mean, I used to show up at my meetings, even when I started at Rosen in 2011. It was like every meeting I went to, it was DPR and Southland, and DPR and Southland. I'm like, who are these guys? Like, why are we on every single job? Because that's what we did was data centers. And so you gained organizational trust, and then you work with individuals, and you gained individual trust. So culturally, the organizations have a lot of trust in each other already through decades of experience and success. And you get that through the hard projects, not the good projects. And then, we meet, we become individuals and we work together, and then the trust excels as well because the companies all put their best people forward.
Great. Thank you.
Yep.
Victor, John, and Simon.
Cool.
Good.
Thank you guys.